There is one rule in physics that we are all told is just the absolute bedrock of reality.
Right, the speed of light.
Exactly. It is constant. It is invariant, the universal speed limit. But welcome to our deep dive, where today we are looking at a stack of research on curvature variable physics, or CVP, that asks a really dangerous question.
What if $10 isn't actually constant everywhere?
I mean, it sounds like pure heresy,
Right.
right? But the central idea is actually quite elegant. The research proposes that the speed of light is conditional.
Conditional on what exactly? Oh, wait, you mean conditional on gravity?
Yes, well, it suggests that light speed actually changes based on the curvature of space-time itself.
Which usually when people try to rewrite Einstein, they just end up breaking the rest of physics. Like if light isn't constant, doesn't my GPS just stop working?
That is the big risk, yeah. But CVP is framed as a controlled extension. It respects local Lorentz invariance.
Meaning, here on Earth, the math just collapses back to standard Einsteinian physics.
Exactly. Anywhere with weak gravity, standard physics works perfectly. But in deep space, near really massive objects, they introduce this thing called the Dillon operator.
Our notes compare this to a refractive index. So they are saying gravity acts like glass or water.
That is a great way to think about it. The theory suggests extreme gravity creates a sort of density in the vacuum. And to measure that density, they rely on the Kretschmann scalar.
I see that term pop up a lot in black hole physics, but what is it actually measuring in this specific context?
Think of the Kretschmann scalar as a gauge for the sheer intensity of the tidal forces, like how violently space-time is being twisted and stretched.
So the theory says this intensity acts like a brake.
Yes, the higher the scalar, the thicker the glass, so to speak, and the slower the light moves relative to that curvature.
But theoretical physics is, full of beautiful math that doesn't actually match reality. How do we test if light is actually hitting the brakes?
We look at the trajectory through astrometric microlensing. Standard relativity says light just bends around a massive object.
But if CVP is right, we won't just see a smooth curve.
Right, we should see caustic crossings. These are specific asymmetrical wobbles in the data from telescopes like Gaia DR4 or LSST.
It is a signature that gravity isn't just bending the path, but actually dragging on the photon itself.
Exactly. The other criticism we always see with new theories is that you can just tune the numbers until they fit the data. The whole under-constrained model problem.
Which is why this source material is so fascinating. It actually proposes a solution to the crisis of reproducibility. They call it the CVP integrity plane.
It shifts the standard of science from trust me to audit me. And they use TEVR, right? Test, evaluation, verification, replication.
Yes, and it relies heavily on something called proof bundles.
It looks like they are borrowing a page from cryptocurrency here. What exactly is a proof bundle?
It is a cryptographically sealed archive. It contains every parameter, every line of code, and every bit of data used to make a claim.
Because science must be deterministic.
Right. If I can't take your bundle, run it on their overlay processor, and get the exact same result, bit for bit, then your theory doesn't count.
So it creates an auditable truth. That concept of reducing hidden variables actually bridges into the wildest part of this stack for me.
The omega theorems.
Yeah, the authors claim this mathematical framework for friction and curvature doesn't stop at physics. It applies to social dynamics. And just as a quick reminder for you listening, we are impartially reporting on what the source material says here. We aren't endorsing any specific worldview.
Right. This is the systems view of the theory. They argue that just as gravity creates curvature in space, conflict creates curvature in social systems.
They apply the same syntropic operators to human interaction. But how do you quantify something abstract, like kindness, using physics equations?
You treat it as an efficiency variable. Theorem 21 defines kindness not as a warm emotion, but as an operator that reduces moral distance.
In a network sense, being kind shortens the path between two nodes, requiring less energy to get things done.
Precisely.
So forgiveness isn't just moral, it is optimization.
That is Theorem 22. It views forgiveness as a mechanism to release injury curvature.
If you hold a grudge, you are maintaining high resistance in the system.
And forgiveness straightens the line, mathematically optimizing the network.
This even extends to how they build AI. They mention AI moral neutrality.
The system explicitly forbids AI from assigning binary good or bad labels to humans. It forces the AI to use a neutral evidence framework instead.
Separating facts from disputes. It preserves human dignity by refusing to flatten a complex person into a database entry.
It really suggests that whether you are a photon or a person, the most efficient path is always the one with the least curvature.
We have gone from light dragging through gravity wells to optimizing social friction, all using the same geometry. So here is a final provocative thought for you to chew on.
Yeah.
If forgiveness and kindness can be modeled as mathematical operators that reduce resistance in a system, are social conflicts actually just unsolved physics equations waiting for the right variable? Thanks for listening to this deep dive. Stay curious.